Hi, hello. Today we are going to see a topic called as your priority encoder under the course called as your digital principle and system design, in which the module number 2 or the unit number 2 combinational circuits. After the titles of your encoders and decoders, we are starting with the topic called as your priority encoder. And as the name itself instincts, okay, so priority encoder is the word, or else it is a device, or it's in a combination circuit which has been designed in such a way to give priority for some inputs. As of before going into the topic of your priority encoder, we need to know what is an encoder is, and then only we can go into the priority encoder. An encoder is a combinational circuit that performs the inverse operation of a decoder. For example, in the previous sessions we have seen about what is a decoder is, and here the encoder does an operation, inverse operation as that of a decoder. With the help of a decoder, we can able to implement, with the help of a decoder and as well as OR gates, we can able to implement any logic functions. So here for an encoder, the number of inputs will be 2 power of your n inputs, and the number of outputs will be equal to your n outputs, and the output line generate the binary code corresponding to the input value. Say example, when your n is equal to 2, your 2 power of your 2, that is equal to 4. So this encoder is of your 4:2 encoder type. So here the number of inputs are your D0, D1, so 4 inputs, so D0, D1, D2 and D3, and your output is just indicated as your XY. So your inputs may be, okay, your input, that is your data lines, can be from your D0 to D3. So you can put the values as, when your D0 is equal to 1, okay, D2, D3, D1, D2, D3 can be anything. So your output is 0, 0. When your D1 is 1, it's your 0, 1, and when your D2 is equal to 1, your output is 1, 0, and your D3 is equal to 1, your output is equal to 1, 1. So what is the why, what is the need for the priority encoder? That is an important task that we have to study. And if there exists a problem under the encoders, means what sort of problem exists, and why we are going for this priority encoder is. The problems with the regular encoders are only one input can be active at any given time. So for example, in the previous thing, so here we can take that if your D0 is equal to 1, okay, D0 is equal to 1 means the other D1, D2, D3 should be equal to 0. If that is the case, only your output will be 0, 0. For example, if D2 is also becoming 1 means, then what will happen, how the output will be, there occurs some redundancy, right? So we are going to prioritize which should be given within priority. For example, D0, D1, the hierarchy is D0, D1, D2 and D3. So when compared to your D1, okay, when compared to D0, your D1 is of high priority. When compared to D0 and D1, your D2 is having some higher priority. When compared to your D1, D0, D1 and D2, this D3 is having your highest priority. So that's what given here. The problem with a regular encoder is only one input can be active at any given time. The output is undefined for the case when more than one input is active simultaneously. That's what I have told in the previous section. When D0 and as well as D2 both are active, means when both are giving a value of 1, what should be the output? That will be a redundant output. We can't speculate. Or for example, if your D1 and D2 are 1 and 1 means, we can't assert the value of your xy as to be, it should be 1, 0 or 0, 1. It can come anything, okay. Multiple times if we are working, means on all the multiple times you will be screening out with different values. So that is the biggest problem that has been faced as of encoders is about. But whereas as of the priority encoder, as I've told, this D1 is having a high priority than D0, and this D2 is having a higher priority than D1 and D0, and this D3 is having a highest priority when compared to your D2, D1 and as well as your D0. So let me take all the values to be 0, 0, 0, 0 means your output will be anything. It is not indicated. It can be XX means it don't care. It can be 0, 0 or 0, 1, 1, 1, whatever it may be. But whereas the output validity is 0. So but whereas when one of your input is equal to 0, say for example here your D0 is fixed with an priority means, then D1, D2 and D3 all the three are 0. okay, then your output is equal to 0 and 0 means they here it is valid, so 1. And when you are d1, now here d1 is set with an priority. When d1 is set with an priority, d1 is having a high priority when compared to d0. Whatsoever may the value of your d0, it can be 1 or 0, okay, but your d1 is 1, right? Now here the xy value should be 0 and 1, and here this is valid, so 1. And say for example now d2 is asserted with the value of 1, you don't want to consider about your d0 or d1, it is given with and don't cares whatsoever the value of your d0 and d1, it could be given as your 0 0 0 1 whatever the value. Here d2 is given with a higher priority, right? So now here the output is equal to 1 0, it's valid. And when your d3 is asserted as 1, okay, then it is having an highest priority when compared to d0, d1 and d2. Now for all the d0, d1 and d2, you can put it as your x and x, which is a don't care function. Okay, in this don't care function it can have any values, but it won't affect the output. The output is only 1 and 1. This is the truth table of your priority encoder. Here one thing we have to do is, when d0 is selected, your d1, d2 and d3 should be 0, okay, to get an output of 0 and 0. But whereas when d1 is given with an priority, d0 can be any value, okay, so the output is equal to 0 and 1. When d2 is given with an priority means d0 and d1 is given with an liberty to take any value, so it's 1 0. And when your d3 is given with an highest priority, then d0, d1 and d2 can take any value. It can be ones or all ones can also be there, okay, but whereas your output is equal to 1 and 1. These 4 states are valid, so this only a validity pin has been used. Now see here, you want to give the expression for your x, okay. When you want to give the expression for your x, see here, for x it's 1, okay. So for 1 it can have any value of 0 or 1. Let you take it as 1 all. When you plot this, here you are getting only d3, okay, but whereas when you go for your next x is equal to 1 means this value, so your d3 dash into your in d2. And when you go for your y, it should be, okay, for y it's your d3, and here for your y what you can do is your d1 d2 dash and d3 dash, d1 d2 dash and d3 dash. Without finding the k-map, we can able to write the expression for this. And for v, okay, this is called as your validity, which could be given as your d0 plus d1 plus d2 plus d3. That's called as your validity pins expression. So in the truth table, x for inputs represents 0 or 1. Good for condensing the truth table. Example, it's x100 means it can be 0 100 or 1100. This means d1 has priority over d0, and d3 has the highest priority, d2 has the next, and d0 has the lowest priority. This I have already told, okay. So when we draw the k-map for the x and y, okay, when you draw the k-map for your x and y, see here, now when you draw the k-map for your x and y, so now we are going to draw the k-map for your x, okay. For the x, what you can do is, this x can vary from your 000 to 111, 000 to 111. It's your 0001 and your 0011 will be there, and 0101 will be there, and as well as your 0110 will be there, 010 see 000 will be there, and your 010 will be there, so up to 000 to 111 will be there. So for such values you can put as assert as 1 here. For such values you can put it as assert as 1 value here, so we'll be getting this totally 8 values will be 1, okay. For here, as of here is about, okay, here you can take this x and x, right? This can have 2 values, so 00 to 11, so 001 and 011 and your 101 and 111, all the values along with the 0 can be appended, right? So here another 4 values, totally 12 ones will be there, okay, totally 12 ones will be there. You can group these 8 can be grouped into one thing, and this 8 can be grouped into one thing, so the expression can be your d2 plus your d3, okay. And now when you go for this, okay, when you go for this, now what we can do is, here also for your y, okay, for your y 1 is there, right? 8 ones, okay, the same 8 ones, you will be getting, okay, you will be getting 8 ones. And next to this, here when you come here, it will be having only two values, so 0 1 0 0 and your 1 1 0 0 1 1 0 0. So when you put like this, these are the two values you will be getting, these are the two values, for example 0 1 0 0 and 1 1 0 0. Okay, so here this 8, here this 8, and as well as this 4. For this 8 you will be getting the value as d3, and for this 4 you will be getting the values of your d1 into your d2 dash. This I have already put there and there itself. Now when you draw, okay, when you draw in for a 4-bit by a priority encoder, the circuit will be like this. Using your AND and OR gates, you have drawn this circuit. And thank you very much for listening, and let me see in the next topic. Thank you.